Now I'm gonna talk about my homework 3. First is problem 1. I use SAT to solve this problem because SAT is faster, it's like dictionary, and also we don't need to check whether it's duplicated. So here initialize the SAT, which is called distance, and we insert all these numbers to the SAT, and then just output like the admin in this set. So we got the distinct numbers. This is like straightforward. And on problem 2, first I assign this array, which is counts. It's constant, so it should be 0 to 9. And I and in this part I generate like 100 random numbers with this, because here it generates numbers in 2 to the 15th minus 1, and here we can get the last digit of these numbers, so it should be like random numbers from 0 to 9. And for each number we just add 1 to the position of this array, and here the output, we just output the numbers in each position of the array. So this is what we have. Problem 3, first I assign two vectors, names and scores, to save the data. And here we input all these data. We push back to save these informations to these two arrays, and then I use the bubble sort to reorder the student with their scores. And every time I swap two students, we need to swap their scores and the names, because they need to have the same name as scores, right? And then here's the output, just output, because we already sort by their scores. We just do the output of the names and scores. So here is the program, and we enter all these students, their information, and then the output should be like this. Then is problem 4. Problem 4 is first the computer generate a number from 0 to from 1 to 100. This one is 0 to 99, and then it's plus 1. And then we just guess whether it's too high, too low, and eventually we will get the answer, because it's just 1 to 100. It's not that big, the number. And then this is straightforward. Then we got the number. And here for the modify problem, problem 4, our computer need to guess the number that we have in 7 steps, because the highest number is 100, and 2 to the 7th is 128, which means we can have 128 distinct values by binary search. So the 7th step would work here, and then we just so the people would think of a number from 1 to 100, and then the computer will guess. So each time, whether the computer guess is too low or too high, and there's output, like the computer will just guess again. Like for example, the number is 65 and the computer guess is 50, and then it will continue guess, and reset is low and high boundary, and the search from 51 to 100, and here it gets the average value here, maybe is 75, or 76. Is 76, and then you will check again, and like 55 is less than 76, then the higher the high boundary should be 76, and then like we can do this in 7 times to guess the number from 1 to 100. And here every time we just we just repeat this, because no matter what, you will guess one time. Like if if the number is 50, then you will just go out of the loop, or if not, then you will just repeat. So we use the do and while loop, and then the uh, yeah, and after this, so I believe there should be like we could add a like something to check this number whether it's right or wrong, but I don't think there's any mistake, because yeah, this is very simple, and then we can get the number if the because after we jump out of the loop, then the number should be the same as like the same as what do you think. So yeah, here is the output, and then it generates the count, and yeah, and the problem is right here. Oh, they are together. This is problem 4. So the number, guess the number 50. Yeah, the number 57. So this is the first part. The 57, and you will just guess from 50. I guess from 50, and then it's like, yeah, this is straightforward. And for here, the number is 23. Then the first guess is 50, and 25. And the medium 25 is 12, and then is greater than 12, so we got the average number from 12 to 25 is 18, and then we do it again, and here we got 23, and the total rounds is 6. So that will be all. Thank you.